All right, hello and welcome to day 3 of Advent of Code. So today we are given a grid containing some numbers, and it's asking us to add up all of the part numbers. And so what this means, or how it defines a part number, is to be any number adjacent to a symbol, even diagonally. And so here, for example, 467 is a part number because the 7 is adjacent to a star. The 114, however, is not a part number because no digit within that number is adjacent to a symbol. Now, I think that the most efficient way to do this problem is to use regular expressions, but I solved it a different way that takes advantage of the fact that a part number is only a part number if at least one of its digits borders a symbol. And with that information, or with that kind of guiding idea, we can use a grid traversal here to simply look through each line and determine which numbers border a symbol, and then to which digits border a symbol, and then to which numbers those digits belong. And then we can identify those numbers as part numbers and add them to our sum. Great. So in order to do that, well, first I guess I should generate the directory that we'll be working in. And so this is just some boilerplate code that I have for each day. It just makes things a little bit simpler. We will begin by creating a grid. And we want our grid to be a two-dimensional vector of characters. And now the way that we'll store values in this grid is simply by iterating through the input. So for int I equals 0, I is less than input.size, I plus plus. For every I, so I kind of represents the row which we're on, we'll initialize a vector called line, which will store all the characters in the current line. And then for int j, which is equal to 0, or it will start at 0, and then that will iterate up to the size of the current line, and we'll increment it by 1. As long as we're not looking at a new line character, then we can append our current character, or push back, I should say. We can push our current character into our line. And then once we are done with the line, we can push the line into grid. And feel free to check that this works with logging everything, but it should be good for now. The next thing we'll want to know is how big our grid is. So we'll get the number of rows, store it as R, and we'll get the number of columns, which is equal to the size of the first row. Or not I, should be 0. Wonderful. And then, so the way that we're going to want to do this is starting by iterating through our grid. So for int r equals 0, r is less than r plus plus. And for every line, we're going to want to start keeping track of our number. So I'm just going to call our number n. Okay? And we also want to keep track of whether or not our number is a part number. And we'll start off by saying our number is not a part number. Great. And so now we can iterate through every character within our row. So for int c equals 0, c is less than c, c plus plus. We can say our current character is equal to the grid at r at c. And if our current character is a digit, is digit of ch, we want to kind of add it to n. But we need to be careful because n, because we're working, it won't simply be like 4 plus 6 plus 7. We want 4 times 100 plus 6 times 10 plus 7 times 1. And so the way we do that is we'll say n is equal to n times 10 plus our current character, And then we need to convert our current character into an integer by subtracting the 0 character. And this works because C++ would otherwise process this character as its ASCII code, which we do not want to happen. Great. And so now we want to do kind of our diagonal, or excuse me, our directional check. So like, let's say for example that we're looking at the 7, we want to look down, to the right, to the left, and then down, and then southwest and southeast as well. And we'll encounter this star on the southeast position. So we can mark 467 as a part number. And so the way we'll do that is by initializing two kind of directional vectors. So there'll be vectors and integers. We'll call one dr, be -1, 0, and 1. And this just represents the ways in which we can move. And then I'll just copy and paste that down, and we'll call that dc. And so for int dr of dr, and for int dc of dc, we just need to make sure we're still in bounds. And so what we'll do is we'll say, as long as RR is less than, well, let's actually check if we need to move on. So we'll say if not RR is less than R and RR is greater than or equal to 0. So if we're out of bounds in the row, or if CC is less than or equal to C, less than C, and CC is greater than or equal to 0, we should continue. Great. Oh, and I did not define RR and CC. So RR is just going to be our new position, so R plus DR, and CC will be the same thing, C plus DC. Wonderful. Okay. Additionally, and this line is not strictly necessary, but I just like to include it. If our DR and DC are both 0, which means we would not be moving, we would just be looking at the current digit, then we also can skip what's next. And so what is next? Well, what's next is checking whether we are at a special character. And so basically, if the character we're looking at is not a digit and it's not equal to a period, then we know that we're looking at a special character. So we can set our part Boolean to true, and we can break out of this loop. Great. And we also need to break out of the loop down here if the number is a part number, because we don't want to keep looking and toggling on and off the is part value. Or I suppose this is not strictly necessary, but it could save some time. Great. And then we can also break out of our, so once we, so we checked if we were working with if we encountered a digit, but let's say we don't encounter a digit. Let's say we are like looking at this period, for example. Well, if we're looking at that period, we know what we should do is add, we should kind of, this should mark the end of our number, right? We know the number has ended. So we should add 467 to our total because it is a part number, and we should clear everything. So we should clear n, and then we should move on. So down here, we'll check if is part. We can add n to our answer, and we can set n equal to 0. We can reset is part, and we can move on. Great. And then the same thing is true once we finish looking at the current line. We should once again check if is part. We can add n to our answer. We can set n equal to 0, and we can set is part equal to false. And this, well, one last thing is that we should only do this kind of directional traversal or iteration. We should only do that if we need to. And the only reason we would need to is if we don't know yet if our number is a part number. But if it is a part number, then we don't need to do this. Or if we know it's a part number, then we don't need to do this. So let's go into the day3 directory, compile our code, and then run it on the test input, and we get 4,361, which is correct. And if we do it on the real input, we get 556,367, which is also correct. Great. Now part 2, it tells us what a gear is. So a gear is any star symbol that is adjacent to exactly two part numbers, and its gear ratio is the result of multiplying those two numbers together. So for example, this star right here is a gear because it's adjacent to 467 and 35. And then the gear ratio of this particular star would be 467 times 35. Great. And then we want to sum over all of the gear ratios. So the way that we can do this is basically start by disregarding any number now that does not border a star, because all we care about are the numbers that border stars. And then so for every star we encounter, we can keep track of which numbers it borders based on its position in the grid. Using a hash map will be the most effective way to do that. And then we can traverse that iterate through that hash map and look at which gears or which stars border exactly two numbers. And the ones that border exactly two numbers are gears, and we want to calculate their gear ratios, and then we can add their gear ratios to our answer. So we'll use essentially the same code that we used in part 1, at least for most of it. So I'll grab all of this, starting here, and move over into part 2 and paste it. And so the first change we'll need to make is having a place to keep track of our gears. Okay, and so we want to map from, let's see, the position. So we'll have like RC. We want to map the row and column of a given gear to a vector of its numbers, right, or the numbers that it borders. So both of these will be vectors. So we'll map from vector int also to vector int. Great. Now the first, or the key here, will always have exactly 2 elements, but the value may have more, depending on how many numbers the gear or a star borders, right? And so now, every time we are on a new line, we want to kind of initialize, or declare, I should say, a vector which will tell us the position of the current gear, right? And then this will become the entry, or the key, for a new entry in our map. Great. And then the next thing we need to modify is that in our diagonal search here, previously we checked for all special characters, but now we can simply check just for the star. So I'll delete this, and then we'll just check if grid RRCC is equal to a star. Well, what do we want to do then? The first thing we need to do is declare a new entry in our map, given or using the position of our gear. Then we want to set our current gear equal to RRCC, right? And then we can set is part equal to true because we've identified the number as a part number. And then basically all of this remains the same, but down here, rather than adding n to our answer, we want to add n into the vector the vector that corresponds to the position of our current gear. So we will do gears at current dot push back n. And then here we want to reset n equal to 0, and we want to say is part equals false. And we also want to clear current gear because we want to leave room for the next RR and CC that we encounter. And then we can just grab this and paste it down here, which this will execute every time we go to a new line. And then finally, we just need to iterate through our map and add all of the gear ratios. So this should be const auto gear of gears. So if the gear has exactly 2 elements, or if it borders exactly 2 numbers, then we want to add the product of those 2 numbers times year.second at 1. We want to add the product of those two numbers to our answer. So if we do crun p2.cpp and we run it on the test input, we get 597, which I already know is wrong. So let me, oh, it's because I used the AND operator here. This should be a multiplier. So I'll recompile. I will run it back on the test input, 467,835. That looks correct. And then we'll just run it on the real input as a sanity check. 89,471,771. That looks good. And then, yeah, so that's essentially it for day 3. All this code, by the way, is on GitHub. I don't think I mentioned that the past 2 days, but in the description, this is available on GitHub. Yeah, if you have any questions, please just leave them in the comments. I'll be back tomorrow for day 4.